So we're actually just going to get in a bit more detail about what we learned yesterday. So we're going to review some stuff from yesterday, and then there's going to be a couple new things. Okay? Now, just about everything that I'm going to show you today, okay, you can use your calculator to help you get this information. So we're going to stay away from memorizing, because memorizing is actually the lowest level of learning. Okay, there's nothing lower than memorizing. It's the easiest to put in, and it's the easiest to lose. Okay, I want you to be able to get that graphing calculator out, look at it, and go, oh yeah, it's going to start in quadrant 2 and end in 4. You don't have to memorize that, right? You'll see it on your calculator. So if we just look at this one here, x squared minus 13x plus 40. Now, by looking at this, remember there's an a value in the front. Doesn't look like it, but it's right there, right here. There's an a there. In our case, what is a? 1. Okay, so this is the same thing as 1x squared minus 13x plus 40. Now, what kind of graph is this? It's a polynomial, quadratic. It would be a quadratic going up or a quadratic going down? Up, because it is a positive. Now, if you forgot that, are you screwed? Are you just out of luck? No, put in your graphing calculator. Boink, it goes up. Oh, okay, there you go, it goes up. So if they ask you, does this quadratic go up or down? Right now, you might be going, oh, crap. What was that again? How did I tell that? How did I put it in? See if it goes up. See if it goes down, right? So we'll just kind of roughly draw it when we put it into our calculator. Actually, we don't have to roughly draw it. I can do it for sure here. Okay, so just a little review of how to put this stuff in, right? You want to put y equals. That's that button. You see where a little arrow is? And your x is here, squared minus 13x plus 40. No, it doesn't matter. If you put a 1, it doesn't change it. And then we're going to hit zoom 6. Zoom 6 is called zoom standard. It brings everybody's calculator back to the original, because if you were graphing somewhere else. Okay, well you can, on that box over there, you can grab one. I should have one hopefully waiting in there for you. Now, this is, so okay, that's this. This is the picture of that equation. So this goes from, now this one's kind of weird. Where do you think this one starts? Which quadrant? Can it start in 1 and end in 1? No, it can't. But this one kind of looks like that. But where do you think, if you kept going with this one, where do you think it would actually have started? It would start in 2. Okay? So this one is going to start in 2 and end in 1. That's called actually the end behavior. They want to know the end behavior. I know that sounds weird, right? But end in 1 is actually called the end behavior. Right? We're just going to translate all this stuff. Now, some students will just look at this and they're like, crap, I don't know, I can't remember. Where does it start? Where does it end? I'd be like, graph it. Put it in your calculator and look. Okay? You don't have to memorize it. The end behavior would be in 1, right? Starts in 2. Now, here's also another thing that can help you. It hits here and here. Okay, now you can count that this would be at 1, 2, 3, 4, 5, and 8. You know, what do I call those things? Zeros, good, or x-ins. Now, this is also the same thing as y equals x minus 5, x minus 8. Now, they're called zeros because if I put 5 in here, what's 5 minus 5? 0. 0 times this? 0. If I put 8 in here, 8 minus 8 is 0. 0 times all of this is 0. That's why it's called the zeros. Do you see how these will be opposite always of this number down here? Now what if I graphed it? I got this. So then I'm pretty sure this is what I should get. And it's multiple choice. Right? There's A, and then there's B, and B is x plus 5, x plus 8. Right? That's going to be a good distractor. Right? And then there's another one totally that I wouldn't have picked. How do I know for sure if this is right without a shadow of a doubt? Anyone got a way I could see if this is actually right? Any guesses? If you put these in, it equals 0. Yeah. Foil it out. Very nice. I even got a better way. Use this thing. So you go to y2. Now theoretically, isn't this supposed to be the same as this? Right? Let's check it. I'm going to put x minus 5, x minus 8. And before I do that, I'm going to go all the way left with my graphing calculator. So you can see I kept hitting this left button till I was over here. Do you see where I'm blinking? And hit enter again. And you'll see it'll turn into a thick line. Now I'm going to hit graph. And you see how that thick line went right over the thin one. Is that good enough proof for me they're identical graphs? Okay. So I'm going to keep inundating you with these tricks all the way through, so when you get to your diploma, you're never going to be wondering, like, I hope I got that right. Right? Yep. Well, you should... no, that one works. Yeah, you should. Except you have different colors. Right? That's the Inspire, isn't it? Yeah, like I don't have the Inspire for, but I can help you later one-on-one. Yes? No, so you didn't put a dark one. It actually drew yours right over top, so you couldn't notice. That's why I put this one darker. See how it's fat now? See, and here's the original. And look at the other one. See, in your other one, because they were both thin, they went on over top of each other, and that's why you'll never know if it was right or not, right? Okay, so I'm always gonna throw these out there so you can, I mean seriously, so you can get 100% on your diploma. If you can, first of all, you're gonna go in with obviously knowing how to do this stuff. But you're going to be able to find every mistake you make on that diploma the second time you go through. Okay, so here is just a bunch of knowledge that's really important, good stuff for study sheets. So we're just going to go through, okay? When a polynomial is in standard form, okay, what's standard form? Ax squared plus bx plus c, right? The maximum number of x-intercepts the graph may have is equal to the degree of the function. That's a lot, okay? The maximum, it doesn't have to be, but it can be, is equal to the degree. So example, I always like extremes. Y equals 10x to the 9. It can have possible 9x intercepts. Now, can it have only one? Yes. Can it have two? Yep. 3? Yep. 4? Yeah. 5? Can it have 10? No. Okay. Now, if I can give you an example, just to be able to show you that if you have an x cubed graph, okay, this is what an x cubed graph could look like. Do you see how we have 1, 2, 3? Okay. An x cubed will always do an s, or kind of a not a very good s. See, that's, do you see, is there any possible way I could have 4? Okay, but is it possible to have 0? No, to have 0 x intercepts with a, because where do x cubes always start? They'll always start in 3 and end in 1, so won't they have to go through the x-axis at least once to get there? So an x cubed could also do this. But to see, I only have one x-intercept. Okay? But the thing I'm trying to tell you is that you won't have 4. Okay, you will have maximum 3, but it doesn't have to be 3. Okay, some x cubed, 3. No, I can show you an x cubed that doesn't have 3. Now, an x squared. So I'm just going to I just want to show you. So an x squared, what is the most it could have? 2. Okay. This would be a good example, I think, of 2 x-intercepts. Could it have 0? How many x-intercepts does that have? 0. Can it have 1? Tough call, because this might be considered 1. Right? But that one's a philosophical one, because it might, that's actually, some people say that's 2, like it hits twice. It does it like the thing of, say that's 3, this is x minus 3 times x minus 3. So the argument there is that happens twice, because it's, right? But let's not get into it. The whole point I'm trying to make is you can't have 0. Okay? And here's my, so this has 2, this has 0. And I don't want to get into this one, but you can't have more, right? Oh, did I say I can't have 0? No, you can. Oh, sorry. Yeah, you can have. Now it depends if it's and we'll find out when it's odd. You'll have, like, that's an even, but an x cubed. X cubes always must go from here to here. Now if it's a negative x cubed, it'll do this. Okay? So you'll never have 0 for an x cubed. Right? It's got to go through at least once, because it's got to go from 3, right? 3 up to 1, or... Now, again, do you have to memorize this stuff? If you're just losing your bearings, put in negative x cubed into your calculator. Right? If you're like, crap, I can't remember what that does, right? Well, it's this easy. If you put in negative x cubed, and then you hit graph, okay, you see, it starts at 2 and ends in 4. As long as you know your quadrants, right? Right? This is quadrant 1, 2, 3, 4. Okay, the maximum number, this is another thing to kind of know, but you don't have to really memorize, you can check it. But the maximum number of turning points is equal to 1 less than the degree of the function. So example, y equals 10x to the 9, we would have a maximum, how many turning points? 8 turning points. This is good stuff to write on a study sheet. You see, it's all these facts. Now, it's not bad to know them, but it is really good to be able to check them, right? Now, what's the next thing? The degree and leading coefficient of the equation of the polynomial indicate the end behavior. Okay? Now, why would the leading coefficient help me know about end behavior? The leading coefficient is this right here, this a value. What does a value tell us? No. If it's negative or positive. So by leading coefficient, we're actually talking about positive or negative. Because if it's positive, it would start here and here, but if it's negative, it would start here and here. And then the degree is a big deal as well. So degree and leading coefficient. Okay, and then another cool thing is there's always going to be, well, it doesn't always have to be, but there'll be a constant term, and that is C. Okay, I'm going to actually just put, let's put if A is positive or negative, and the C up here is our constant. That's what C stands for. So if you had 3x squared plus 2x plus 5, guess what the y-intercept is? Equal 5. And that's because if you ever want to find the y-intercept, make x equal 0. Well, what happens if I put 0 here? This goes away. If I put 0 here, this goes away. So I'm only left with 5. Okay? Now, and a lot of people are like, oh, I always forget that. Well, when you look here, if you, this point here, what is the coordinate of that point? 0, 5, right? What is x on the y-axis? Always 0, right? So it kind of makes sense. So how do you want to find the y-intercept? Make x equal 0. Why would it make x equal 0? Because every time x is 0, I guarantee you on the y-axis, right? Okay, important things to remember. Linear and cubic polynomial functions with positive leading coefficients have similar end behavior. Linear and cubic.
Mr. McBurney, please contact the office. Mr. McBurney, please contact the office.
Okay, so linear is x and cubic is x cubed. Have the same similar end behavior, and linear and cubic functions with negative leading coefficients have similar end behavior. So what does that mean? Okay, here's a positive linear. A positive linear would go like this. Or I don't want to do that exactly. Like it can go like that. And a positive cubic polynomial would go like this. Do you see how they have the same end behavior? They start in 3 and end in 1. Start in 3, end in 1. Now it says the linear and cubic functions with negative leading coefficient. Well, if it's a negative leading coefficient, I guarantee that your linear will be going down, right? If it's a negative cubic, it'll go like that. So why do they have similar end behavior? Because they both start in 2 and end in 4.
Mrs. Ferguson, please contact the office. Mrs. Ferguson, contact the office, please.
This is negative. So this is a negative x, and this is a negative x cubed. This is positive. This is a positive x and a positive x cubed. They have the same end behavior. And the reason why, what's the exponent on x? 1. And we're going to learn pretty soon that when your exponent is an odd number, they all have the same start and end spot. Okay? And if they're all even, they all have the same start and end spot. I wonder what's going to be on the quiz tomorrow, hey? The only time you add exponents is if you had x to the 5 times x to the 3. That's x to the 8. When you multiply powers with the same base, that's the only time you can add exponents. Okay? Okay, so here's a whole bunch of rules, but I want to try to make them not these like rules, right? I hope they make sense as we do these. Now, this is if the leading coefficient is negative, then the graph of the function extends from 2 and ends in 4. Okay? Now, this is a negative odd degree polynomial. Now let's put a circle around the negative, because some people later look at it and go, was I meant to do a dash, or did I mean to put a negative there? So a negative odd degree polynomial. Now, I just want you to watch for a second, because if I gave you this on a multiple choice test, and I said, what is the end behavior of a negative odd degree polynomial? I ask you that. What is the end? And it's a simple multiple choice question. I'm going to put quadrant 1, quadrant 2, quadrant 3, quadrant 4. What is the end behavior? Now, there's two ways you can go with this. You can be like, I memorized that. I know exactly where it is. But what if you didn't memorize it? How could you get this right? Just from this information that I've given you. What would you put in there? No, you don't have an equation. That's your question. That's all your question is. Yes? Put in negative x cubed. Is this identical to this question? See, that is the math for that entire question. So, or negative x to the 19, or negative x to the 21. Is that all describing this? So, I don't want you to have to memorize it, you guys. I want you to go, oh yeah, I'm just going to do it. Okay, well there's that one. But let's just, for the sake of, I'm going to go negative x to the 21. Did it start in 2 and end in 4? Yeah, I mean, you give them to me all day long. If it's a negative with an odd degree, I'll put it in my calculator and I'll tell you exactly what it is. Now, maybe you can't tell me right now, but you're just like, give me a second. Oh, it's going to start in 2 and end in 4. Okay? And that's not bad for a test. If it takes you 3 seconds to get a question on your test, that's not bad. Okay? The person that memorizes it, they can get it in 1, but you got to watch when you memorize stuff sometimes, because it's not based on common sense. It's based on memorization. And like my son's learning his timetables now. I'll ask him 8 times 3 and he'll go 21. I'll go, it's not 21. He's like, oh, really? Oh, okay. Because he just memorized them, right? And then I go, come on, add them up. 8, 8, 8. He's like, oh, 24, right? So he's memorizing, but he doesn't really, like, what if he got it wrong? Like, he's just going to write down 24 in his quiz, hand it in, think he's got it, right? So I want to try to get us away from memorizing, because Memorizing's hard work. It's and not reliable, right? But if you've done it enough and you remember it, but you're like, hey, this is a big test. This is my diploma. It's worth 30% of my mark. I just want to check. I'm just going to check and make sure I'm right. And you're going to put it in your calculator and you go, yeah, okay, okay, that's good. I got it. Okay? Someone had a question here. Or did I answer it? Okay? So, does it make sense that if the leading coefficient is negative, then the graph of the function extends from quadrant 2 to quadrant 4? Okay, and what are some examples? Let's put some examples. Negative x to the 5. Negative, like, let's just go negative 2x to the 23. How about negative 5x to the 21 plus 2x? Like, any of those would do that same thing. Yep?
The early question that you wrote as like somebody who's asking a test, and it asked the derivative, why didn't you describe it?
I just put 4.
Like say negative 5x is your answer, or negative 5x to 21.
Mm-hmm.
Why would you put that and not describe it?
Oh, no, I would put this into my calculator, and then I saw where it ended, and I'm going to pick C, which was, because they're always going to be mixed up, I'm going to pick this one, quadrant 4. Yeah, so I actually didn't finish answering the question. I just looked at it and said it's ending in 4. And I'd do like 5 of them, right? I'd go like negative x to the 5, and I'd go negative 3x to the 20. So I saw it like 5 times. I guarantee it ends in 4 every time, right? Because nothing is going to make you madder than you get those questions wrong, right? And I've been teaching diploma courses for a lot of years. Students come out of the gym and they're like, what'd you get for 5? Right? Quadrant 4. Oh, me too. Did you graph it? Yeah, I graphed it, right? Or if they're like, I got quadrant 3. You're like, no, it's not quadrant 3, right? And the 2 kids, they'll fight, right? They're like, no, I know it is, right? They're like chasing me down the halls. Which one? I said, did you graph it? One kid, I graphed it. The other kid, no, I didn't. Why not? It was right in front. You had a graphing calculator. Were you drawing lines with it? Like, what were you using that thing for, right? You know, so I never want to have that conversation. I want you to say, I graphed it. I guarantee I graphed like 5 different negative, odd functions, and they all ended in 4. Okay? No guessing, right? We don't want any guessing on that diploma. Okay, where am I? I'm lost. Oh no, I'm here. Okay, so what do you see how degree 1, degree 3, right? Those are what kind of degrees? What are 1 and 3? What kind of numbers are those? Odds. And since they're starting in 3 and ending in 1, right? So this would be a positive odd degree polynomial. And they will all start in 3 and end in 1. And you would be here for the rest of your life trying to find me an example that doesn't work. Okay, that's a pretty good rule. Okay, now, the next we're looking at quadratic. So these, if the leading coefficient is negative, now it's degree 2, right? And there's the thing. Do you see how it starts in 3 and ends in 4? So what do we know about, this is called a negative, right, even degree polynomial. Okay, give me an example of a negative even degree polynomial. All ears, yep. Negative x squared. Give me another one. Negative x to the 6. Any even degree. right? So negative x to the 14. And again, I want to just show you that if I did a negative x to the 4, starts in 3, ends in 4. Okay, what if I change that to 14? Okay, it will still start in 3, end in 4. What do you think a positive will always do? So a positive even degree will always start in 2, end in 1. Okay, and these even, the negative even degree, I never start, it will start in 3, end in 4. Always, always, always. So a positive even degree would be like x squared, 5x to the 4, 7x to the 16. And do you see how I'm putting odd numbers in the front? Does this number have anything to do with end behavior? Only if it's positive or negative, right? But I know I'm going to get students that are going to say, oh, that's an odd degree. I'm like, what are you talking about? Why is it odd? Because of the 7. I go, no, no, no. What is degree always referring to? The exponent. Okay? Another thing to write on your study sheet, right? Degree equals biggest exponent, right? That was off your quiz today. Degree will equal largest exponent. Okay? And they can be tricky, right? Like they can do things like this, where they'll be like, y, oops, that's a really bad y. Y equals x to the 4 plus x cubed plus 2x to the 5. And they'll ask, what's the degree? It's 5, yeah. What's the biggest distractor? What do you think would be the best other answer to put if you were making a multiple choice test? Okay, 7's another one, yeah. And then this is the, students say 4 for that one all the time because they look at the very first one. No, look through all of them and go 5 wins. This is degree 5. Okay? I've seen a lot of diplomas. I know all the tricks that they try to pull. And they do stuff like that. But never should you ever get caught on these questions. Now, let's just, without graphing, determine the following characteristics of each function using the equation. Okay, and I think we need the equation from the next page. Okay, so here's all the things we're going to find. Number of possible x-intercepts, domain, y-intercept, range, end behavior, a number of possible turning points. Lots to know. Okay, so here we are. Now, the first, what is the number of x-intercepts? How do we get 2? What is the rule? Let's look. I got so many pages here, I can't find my rules. The maximum number of x-intercepts of the graph may have is equal to the degree of the function. What is the degree? 1. So 1, right? There's a 1 right there. So what's the maximum number of x-intercepts? Is 1. Because degree is 1. In fact, it's impossible to have 0. What kind of graph is 3x minus 5? Linear. Can you try and do a linear graph for me that will not go through the x-axis? Can you do it? Like, you like, oh, I'm going to start way over here. Ha ha ha. Well, I don't know. I think you still went through the x-axis. Okay? Go crazy. Have some fun with it. You'll never do it. Okay? So you can't actually have 0. But the rule is that's the maximum number. Okay? What's the y-intercept? Close, except 100% opposite. -5. Okay, domain. What's the domain of a line? This is always everybody's favorites, eh? They see domain and range and they're like, oh, really? But the diploma loves domain and range like you wouldn't believe. It's like 80% of their questions have domain and range in them. Because they love them. Because you hate them. That's why. Okay? Y, and then the range. Y is in the reals as well. Now, end behavior. Because this is the graph, right? Like that's a graph of a line. So all x's will be on it and all y's will be on it. Yeah, well, you know that no matter what, like if here's your x-axis, right? Every x hits this line. And every y hits this line, right? No matter where you go, every y is going to be on that line. End behavior. Three, 2, 1. And if you forget that, graph it. Graph a, well, this one says to do it without graphing, but if you're writing a test, and it would never say that, right? I'm not going to give you a test like that because it's not even realistic. Do you get to take your graphing calculator into your diploma? Yes, right? Diploma's not going to say, okay, you're not allowed to use your graphing calculator for this. You're like, ah, crap, that sucks.
Good afternoon, staff and students, and please excuse the interruption. Just a reminder and some clarification about what will be going on this afternoon. First of all, in about...
We'll go. Okay, what is this one here? What was the last question? Number of turning points, yeah. What was the rule? But what's the rule? 1 less than degree is the maximum you can have, right? So this will definitely have 0. Okay, for this I just want to talk about, so x ints in the next one. How many? 2 max, right? What is the y int? 8, right? That constant. Let's not, we don't care about domain range. How about end behavior? What do we know about an even negative? Starts in 3, ends in 4. Okay, what is the maximum number of turning points? Max turns equals 1. It's always got to be 1 less than the degree. Okay, how about C? X-intercepts possible. Equals 3, right? What's the rule? Equals degree. Now let's put max in front, right? Because it doesn't have to have 3. It can have 1 if it wants. But maximum number. What would be the y int? Don't get caught this time. -10. Okay. End behavior. So this is a positive odd, correct? Where do positive odds always start? A positive odd. See? It's positive and it's odd. So it will start in 3 and end in 1. Okay, and max turning points? 2. Okay, and then the rest were just like graphing and stuff like that. We don't have to keep doing them. We don't need to beat this horse to death, right? So, we're doing page 120 and 121. Of course, we would all finished our homework today, but we have to go to an assembly. Okay, so can you kind of start to see what I want you to know tomorrow? Okay, what would my quiz be on? Okay, if you're going to catch a rabbit, try and think like the rabbit, right? So think, what would I want you to know tomorrow?